Okay. Chapter 15, worksheet, page 451, problem 1. The licensed prescriber orders 500 milliliters of dextran to be infused over 24 hours. How many milliliters per hour should the IV pump be programmed for? Okay, so the volume that we're going to administer is the 500 milliliters. The time we're administering that over is 24 hours. We're literally just going to take 500 divided by 24. And that's going to be 20.8 milliliters per hour. Okay? But we can't set our pumps for decimals, and we don't want to under administer our medication to our patient, so we round these values up to the whole number. So it's going to be 21 milliliters per hour. Okay, number 2, a patient with genital herpes has an order for acyclovir 400 milligrams IV PB Q8 hours. The acyclovir is dissolved in 100 milliliters of 0.9% NS and is to be diffused over 1 hour. How many milliliters per hour should the IV pump be programmed for? So again, we focus on the volume, which is going to be the 100 milliliters of 0.9% NS. Again, that is another solution that your medication can be dissolved in when it goes into your IV bag. So it's the 100 milliliters, and we're going to diffuse it or be infused over 1 hour. So 100 divided by 1, I know it's silly, it's just 100 milliliters per hour. Okay, number 3. Amikacin 80 milligrams is ordered IVPB Q12 hours. The amikacin is dissolved in 100 milliliters of D5W and is to be infused over 30 minutes with a tubing drop factor of 15 GTT per milliliter. That also reads 15 drops per milliliter. So how many drops per minute should be given? So the same thing, we start with our volume, which is going to be the 100 milliliters of D5W, is going to be infused over 30 minutes. We have a tubing factor of 15 drops per milliliter. So my units of milliliters are going to cancel, and then I'm going to cancel 0. So I have 10 times 15, which is 150 divided by 3, which is going to be 50 drops per minute. So 10 times 15 divided by 3 is going to give us 50 GTT or drops per minute. Okay, number 4. The licensed prescriber orders 3,000 milliliters of total parenteral nutrition to be infused from 1900 hours to 700 hours. How many milliliters per hour should the IV pump be programmed? Okay, so again, we start with our volume. It's going to be 3,000 milliliters. And now we have to figure out from 1900 to 7 o'clock, how many hours is that total? So we have 19, 20, 21, 22, 23, 24, and then we start again. 1, 2, 3, 4, 5, 6, 7. So that's 12 hours. And we're just going to go ahead and divide that. It's 3,000 divided by 12 hours is going to be 250 Hold on, guys. Okay, well, never mind. They didn't want to talk. All right. Where are we at? Okay, so I'm sorry. That comes out to 250 milliliters per hour. Okay, number 5. A patient with peptic ulcer disease has famotidine 20 milligrams in 100 milliliters D5W ordered Q12 hours. The famotidine is to be infused over 30 minutes with a tubing factor of 10 drops per milliliter. How many drops per minute should be given? So again, we take our volume, which is going to be the 100 milliliters. We're going to infuse it over 30 minutes. And we have a drop factor of 10 drops per milliliter. So our units of milliliters cancel. Our trillion 0 cancels. So we have 10 times 10 is 100 divided by 3. And that's going to give us 33.3. And again, we typically don't want to underdose, but we need to be careful. So here, I know this is a funky chapter. So here we have 33.3, what is it, drops per minute. But we're going to go ahead and follow our rounding rules, and we're going to go ahead and round down to 33 drops per minute. Okay. So 6, a malnourished patient has an order for 500 milliliters of fat emulsion 10% to be infused over 6 hours. How many milliliters per hour should the IV pump be programmed for? Excuse me. Okay, so again, the volume is 500 milliliters. The time for infusion is 6 hours. So we're going to take 500 divided by 6. And that's going to give us 83.3 milliliters per hour. And we're going to go ahead, follow our rounding rules, and round down to 83 milliliters per hour. Okay. Number 7, an order is received to infuse penicillin G 4 million units in 10 and 100 milliliters of D5W Q12H. The tubing drop factor is 10 drops per milliliter, and the penicillin should be infused over 60 minutes. How many drops per minute should be given? So again, we start with our volume, 100 milliliters. Our IV is to be infused over 60 minutes. And we have a tubing factor of 10 drops per minute. Oh, no, I'm sorry, per milliliter. Like, that doesn't even make sense. Okay, so our milliliters are going to cancel. And then we have a trillion 0 that'll cancel as well. So we're going to be left with 100 divided by 6. And that's going to give us 16.66 drops per minute. We're going to follow our rounding rules and round up to 17 drops per minute. Number 8. A patient with hypokalemia has orders for potassium 60 MEQs in 250 milliliters of D5W. The facility's policy states to infuse the potassium at 20 MEQs per hour. How many milliliters per hour should the IV pump be programmed for? Okay, so here we know we have 250 milliliters of our infusion, right, of our solution. But this one has MEQs, and so our drop factor also has units of MEQs. So in this problem, we still do need to maintain that prescriber's orders of medication. So it's 250 milliliters, and in those 250 milliliters, we have 60 MEQs. And then our drop factor, or the infusion rate, is 20 MEQs per hour. Okay, so then our units of MEQs are going to cancel each other. So we're left with milliliters per hour, which is what our problem is telling us to solve in. How many milliliters per hour should the pump be programmed for? Okay, so then our trailing zeros are going to cancel. We're going to have 250 times 2, and then divide by 6. And that's going to give us 83.3 milliliters per hour. And again, we're going to follow our rounding rules. So it's going to be 83 milliliters per hour. Okay, number 9. A post-operative patient has ceftriaxone 1 gram ordered, 9 Q8 hours. The I don't know what that is dissolved in 50 milliliters of D5W and is to be infused over 30 minutes. The tubing factor is 60 drops per milliliter. So how many drops per minute should be given? So our volume is 50 milliliters. Our time frame is 30 minutes. Our tubing factor is 60 drops per milliliter. Our units of milliliters are going to cancel. A trailing zero is going to cancel. So I have 5 times 60 divided by 3. And that's going to give me 100 drops per minute. Okay. Number 10, a post-operative patient has an order for 1,000 milliliters of LR over 10 hours. How many milliliters per hour? So again, 1,000 milliliters is our volume, and we're infusing that over 10 hours. So we cancel a trailing zero, and we're left with 100 milliliters per hour. Okay, 11. A patient with sepsis has an order for ceftriaxone 1 gram in 50 milliliters of D5W IVPB over 15 minutes. The drop factor is 60 drops per milliliter. How many drops per minute? Okay, so our volume again is 50 milliliters. Our time frame is 15 minutes. And our drop factor is 60 drops per milliliter. Our unit of milliliter is going to cancel, and then we're just going to go ahead and multiply that. 50 times 60 and divide by 15. And that's going to give us 200 drops per minute. Okay, 12. A patient with a methicillin-resistant Staphylococcus aureus infection has ciprofloxacin 400 milligrams and 200 milliliters D5W ordered. So our volume is the 200 milliliters. The pharmacy recommends that the ciprofloxacin be infused at a rate of 200 milligrams per hour with an IV pump. How many milliliters per hour should the IV pump be programmed for? Okay, so this one has, all right, what do you want? It has 200 milligrams per hour. Okay, so this one we are going to use the volume. And in this particular case, we are going to use the doctor's order of 400 milligrams because our flow rate tells us that we need to use the units of milligrams. So again, it recommends that the ciprofloxacin be infused at a rate of 200 milligrams per hour. So that's telling us we do need to use this prescribed medication amount, okay, so that our units are going to cancel. And our infused rate is 200 milligrams per hour. Our units of milligrams are going to cancel, and now we're left with milliliters per hour, which is what the question is asking us for. Okay, so we're going to go ahead and cancel some trailing zeros. So it's going to be 2 times 200 is 400 divided by 4, which is going to give me 100 milliliters per hour. Okay, number 13. A patient with anuria has an order for 1,000 milliliters of 0.9% NS to be infused over 1 hour. The tubing drop factor is 10 drops per milliliter. How many drops per minute? Okay, so we have 1,000 milliliters is our volume. It's going to be infused over 1 hour. Our drop factor is 10 drops per milliliter, but the problem also wants us to solve in minutes, so we need to convert our 1 hour into minutes. So 1 hour is equal to 60 minutes. I'm going to cancel my unit of hours out. So now I'm left with drops per minute, which is what the question is asking us for, okay? And again, we'll cancel trailing zeros. So that's 1,000 times 1. It's 1,000 divided by 6. And that's going to be 166.6 drops per minute. And we're going to round that to 167 drops per minute. Okay, 14. After surgery, a patient has an order for 500 milliliters of D5W 0.45 NS to be infused over 4 hours. How many milliliters per hour? So again, our volume is 500 milliliters. Our infused time frame is 4 hours. So we're just going to take 500 divided by 4, and that's 125 milliliters per hour. Okay, 15. After a total hip replacement, a patient has an order of ketorolac, 60 milligrams IV PB Q6H over 15 minutes. The medication is diluted in 25 milliliters of D5W. The tubing factor is 15 drops per milliliter. How many drops per minute? So the volume is 25 milliliters. The diffusion is over 15 minutes. The tubing drop factor is 15 drops per milliliter. So our units of milliliters are going to cancel, and this 15 is going to cancel this 15. So we're left with 25 drops per minute. Okay, 16. A terminal patient has an order for hydromorphone at 0.5 milligrams per hour by continuous drip, given a bag with a concentration of 20 milligrams hydromorphone, I don't know, in 100 milliliters of D5W, how many milliliters per hour should the IV pump be programmed for? Okay, so again, our volume is the 100 milliliters. Our drop factor is 0.5 milligrams per hour. And again, because our drop factor has the units of milligrams, we also need to include the doctor's original prescribed order. And so for this one, the concentration is 20 milligrams per 100 milliliters. Okay? And so here we're going to have our units of milligrams cancel. And we can cancel a trailing zero. So it's going to be 10 times 0.5 divided by 2. And that's going to give us 2.5 milliliters per hour. We're going to follow our rounding rules and round up to 3 milliliters per hour. Okay, 17. A patient with peptic ulcer disease has an order for famotidine 20 milligrams IV PB Q12H over 15 minutes. The famotidine is diluted in 25 milliliters, so there's our volume, of D5W, and the tubing factor is 20 drops per milliliter, and this was ordered over 15 minutes. And the tubing factor is 20 drops per milliliter. So our units of milliliters are going to cancel. So I'm just going to take 25 times 20 and divide that by 15. And that's going to give me 33.3 drops per minute. We're going to round that to 33 drops per minute. Okay, number 18. Excuse me, guys. A patient with alcoholism has an order for magnesium sulfate 2 grams in 100 milliliters of D5W. So again, it's 100 milliliters of the D5W, and the pharmacy recommends that the magnesium be infused at a rate of 1 gram per hour. So we're infusing it at 1 gram per hour. And again, because our diffusion rate is telling us to use this grams, we're going to go ahead and here use the 2 grams. So our units of grams will cancel, and we're left with milliliters per hour, which is what the problem is asking us for. So it's just 100 divided by 2 is 50 milliliters per hour. Okay, 19. A patient with aplastic anemia has an order for 1 unit of packed red blood cells, just 250 milliliters, to be infused. The facility's policy states to infuse the blood over 4 hours. The tubing drop factor is 20 drops per milliliter. How many drops per minute? Okay, so again, our volume is 250 milliliters. Our time frame is 4 hours. Our tubing factor is 20 drops per minute, per milliliter, sorry. Our units of milliliters are going to cancel. And 19 is asking us for how many drops per minute. So we need to go ahead and convert our time 1 hour is equal to 60 minutes. So we can cancel our unit of hours. Okay, and then we can cancel a trailing 0 here. So we're left with 250 times 2, it's going to give us 500, and then divided by 4 and divide by 6. And that's going to give us 20.8 drops per minute. And then we're going to round that to 21 drops per minute. Okay, number 20. A patient has an order of Afirmax 1,000 milligrams and 100 milliliters of normal saline over 15 minutes for pain. How many milliliters per hour should be given? So, okay, our volume is 100 milliliters. We're going to administer this over 15 minutes. But the problem wants us to have units of milliliters per hour. So I know I need to convert my units of minutes, so 60 minutes to 1 hour. So I can cancel my units of minutes. Okay, so that's going to be 100 times 60 divided by 15. So that's going to give me 400 milliliters per hour. Okay, 21. A patient with hypokalemia has an order for 40 MEQs of potassium to be infused intravenously. The potassium is diluted in 200 milliliters of D5W. The facility's policy states to infuse IV potassium at a rate of 10 MEQs per hour. So again, it's a problem with MEQs, and we're typically going to keep our MEQs in our problem setup because it's part of our diffusion rate. Okay, so our volume was 400, oops, I'm sorry. Our volume is 200 milliliters. Our order is 40 MEQs. Our infusion rate is 10 MEQs per hour. So our units of MEQs are going to cancel, and we're going to have a trailing 0 cancel. And the problem is asking us for milliliters per hour. So it's 200 times 1 is 200, divided by 4 is going to be 50 milliliters per hour. Okay, 22. A patient with Crohn's disease has an order for TPN from 2,200 hours to 800 hours. The total volume of the TPN bag is 1,350 milliliters. So our volume is 1,350 milliliters. How many milliliters per hour should the IV pump be programmed for? Okay, so we have to figure out how many hours that is. So 22, 23, 24, 1, 2, 3, 4, 5, 6, 7, 8. So there's a total of 10 hours that transpire in that time frame. So it's 1,350 milliliters divided by 10 hours. We can cancel a trailing 0, and that leaves us with 135 milliliters per hour. Okay, 23. A patient with hypomagnesemia has an order for magnesium sulfate 2 grams in 50 milliliters D5W IV. A pharmacist recommends that the magnesium be infused at 1 gram per hour. How many milliliters per hour? Okay, so again, our volume is 50 milliliters. Our infused rate tells us there's a 1 gram per hour. And because this gram is used in the infuse rate, we know that we're also going to keep the order. So it's 2 grams in 50 milliliters. And then our units of grams will go ahead and cancel now. And so it's just 50 divided by 2, which is going to give you 25 milliliters per hour. Okay, number 24. A patient with herpes simplex virus 1 has acyclovir 700 milligrams in 200 milliliters. D5W ordered to infuse over 1 hour. How many milliliters per hour? So it's 200 milliliters. It's diffused over 1 hour. There's nothing to simplify really, so it's just 200 milliliters per hour. So don't get confused, don't second guess yourself. Some of these problems really are just that simple, and they're just making sure, one, you can identify what the volume is that you're administering to your patient in their IV bag and over what appropriate time frame. Okay, so 25. A patient with anasarca has albumin 25%, 100 milliliters ordered over 30 minutes. So it's 100 milliliters is our volume. Our time frame is 30 minutes. The tubing drop factor is 20 drops per milliliter. Our units of milliliters are going to cancel. We have a trailing 0 cancel. So we're left with 100 times 2. So that's going to be 200 divided by 3, which is going to give us 66.6 drops per minute. So we're going to round that to 67 drops per minute. All right, 26. After the patient in question, 25, receives her albumin, the licensed prescriber orders furosemide 100 milligrams in 50 milliliters of D5W to be given over 30 minutes. How many milliliters per hour should the IV pump be set for? Okay, so the volume administered is 50 milliliters. The time frame is over 30 minutes. But they're asking us for milliliters per hour. So we need to go ahead and convert 60 minutes per 1 hour. Cancel our unit of minutes. Cancel a trailing 0. So you're left with 50 times 6 divided by 3. And that's going to be 100 milliliters per hour. Okay, 27. A patient with ordered antibiotic allergies, with multiple antibiotic allergies has a urinary tract infection. Amikacin 250 milligrams IVPV QH8H is ordered over 1 hour. The amikacin is dissolved in 200 milliliters of D5W. So our volume is 200 milliliters D5W. And the time frame is ordered over 1 hour. Okay, and our drop factor is 20 drops per milliliter. So our unit of milliliters is going to cancel, and it's 200 times 20, and it's in, hours, and this problem is asking us how many drops per minute. So again, we need to convert our time. 1 hour has 60 minutes. Our units of hours are going to cancel, and we can cancel a trailing 0. So 200 times 2 is 400 divided by 6. And that's going to give us 66.6 drops per minute. And we round to 67 drops per minute. Okay. 28. After surgery, a patient is hemorrhaging and has Amicar 8 grams over 8 hours ordered. The Amicar is diluted in 500 milliliters of 0.9% NS. How many milliliters per hour should the IV pump be set for? Okay, so it's 500 milliliters and it's administered over 8 hours. Okay, so then just take 500 divided by 8. And that's going to give you 62.5 milliliters per hour. We're going to round, and that's going to be 63 milliliters per hour. Okay, question 29. A patient with rapid atrial flutter has an order for diltiazem at 5 milligrams per hour. The diltiazem concentration is 200 milligrams in 250 milliliters of 0.9% NS. How many milliliters per hour should the IV pump be set for? Okay, so again, we have an order that's giving us a flow rate that has the 5 milligrams per hour. So we're going to use our volume, which is 250 milliliters. And we're also going to use our order. It has a concentration of 200 milligrams per 250 milliliters. And then our flow rate is 5 milligrams per hour. So 5 milligrams per 1 hour. So our milligrams are going to cancel. And we're going to go ahead and take cancel a trailing 0. So we're left with 25 times 5 divided by 20, which is going to give us 6.25 milliliters per hour. And we're going to round that to 6 milliliters per hour. Okay. And then number 30. A malnourished patient has folic acid 1 milligram in 50 milliliters of 0.9 NS ordered to infuse over 30 minutes. The IV pump is not available. The nurse chooses a tubing with a 60 drops per milliliter drop factor. How many drops per minute should be given? Okay, so our volume is 50 milliliters. Okay. Our time period it's going to be infused over is 30 minutes. And we have a drop factor of 60 drops per milliliter. So our units of milliliters are going to cancel. And then we have a trailing 0 that's also going to cancel. So we have 50 times 6 is 300 divided by 3 is 100 drops per minute. Okay. 31. Vancomycin 1250 milligrams in 250 milliliters of D5W is ordered to infuse over 2 hours. How many milliliters per hour should the IV pump be set for? Okay, so our volume is 250 milliliters. We're infusing that over 2 hours. So go ahead, solve that. So 250 divided by 2, it's going to be 125 milliliters per hour. Okay, 32. A patient with a blood urea nitrogen level of 52 with oliguria and a blood pressure of 90/50 milligrams mercury, the licensed prescriber orders 100 milliliters of 0.9 NS. So we know our volume is 1,000 milliliters to be infused over 10 hours. How many milliliters per hour? So cancel a trailing zero. That's just going to be 100 milliliters per hour. Okay, 33. Using the Parkland formula, the fluid requirements for a patient with severe burns reveal that 9,600 milliliters should be infused over 8 hours. How many milliliters per hour? So you're just going to take 9,600 and divide it by 8. And that's going to give you 1,200 milliliters per hour. Okay, 34. A patient with IV immunoglobulin G, IgG, 100 milliliters is ordered over 3 hours. So our volume is 100 milliliters, and it's ordered over 3 hours. How many milliliters per hour? So 100 divided by 3 is just going to be 33.3 milliliters per hour, and we're going to round that to 33 mLs per hour. Okay, 35. A patient with rapid atrial fibrillation has an order for diltiazem at 20 milligrams per hour. The diltiazem concentration is 100 milligrams in 100 milliliters. So 100 milliliters with 100 milligrams. And we have an order for 20 milligrams per hour. And how many milliliters per hour should be the IV pump be set for? Okay, so our units of milligrams will cancel, and we have a trailing zero here that'll cancel, and then another trailing zero there that'll cancel. So it's going to be 10 times 2 is just going to be 20 milliliters per hour. Okay, 36. 36. A stat dose of piperacillin tazobactam 3.375 milligrams in 100 milliliters of 0.9 NS is ordered to be given over 15 minutes. How many milliliters per hour? Okay, so we're taking our volume, which is 100 milliliters. We're ordered to be given over 15 minutes. That's our time frame. But we want our pump set in milliliters per hour. So I need to go ahead and convert my minutes to hours. So take 100 times 60 and divide by 15. And that's going to give you 400 milliliters per hour. Okay, 37. A patient with vancomycin-resistant enterococci, has linezolid 600 milligrams intravenously ordered over 2 hours every 12 hours. How many milliliters per hour should the nurse program the pump for? Okay, so we want milliliters per hour. So we need to look at what our concentration is on this label. Okay, so they're telling us the order is 600 milligrams. This is kind of going back to how we were doing in how we were calculating our problems in the previous chapters. Okay, so the doctor's order is 100 milligrams intravenously over 2 hours every 12 hours. So the time frame that we're going to focus on is they're receiving that 600 milligrams over 2 hours. And we'll repeat this at a frequency of every 12 hours. So don't mix up the two time frames that they're giving you. They're infusing this 600 milligrams over 2 hours, but they're going to repeat this dose every 12 hours. But we're going to leave the 12 hours out of our calculations because that's our frequency order. It's not part of our IV flow rate. Okay. And then we have to look at our label because this is not in a flow rate of milliliters per hour. So we're going to need milliliters, and our label is telling us that there are 600 milligrams per 300 milliliters. So this 600 is going to cancel this 600, and my units of milligrams are also going to cancel. So I'm left with 300 milliliters per 2 hours. So 300 divided by 2 is 150 milliliters per hour. And so like that one's a good practice. Number 37, I would circle it just because one, they're giving you a doctor's order, but they're not giving you really a flow rate or a concentration. And again, remember, we're working in IV pumps right now. So because we have information that's inconsistent with an IV pump, that kind of tells us right here, since we're only given these units in milligrams intravenously, we need to look at our label and see if there's some concentration information that we can use to finish our calculation. And again, right here underneath our trade name and our generic name is our concentration or dosage strength. So it's 600 milligrams per the 300 milliliters. And so that's the information we're going to use in order to get the appropriate answer in units of milliliters per hour. And that's basically it for this chapter, guys.